Hello, my dear students. How are you all? I am fine. I am Khandukar Fazder Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. During this pandemic situation, welcome you all to our online chemistry class. My dear students, today we discuss about some important creative question and some important MCQ question from chemistry second paper chapter 3 quantitative chemistry. So let's we start our online chemistry class. My dear students, now I discuss with you some important creative question from chemistry second paper chapter 3 quantitative chemistry. Our first system is here given solution A 1% sulfuric acid 200 ml and solution B sodium hydroxide 300 ml decimolar solution. That means the molar concentration of sodium hydroxide is 0.1 molar. So our first question is what amount of 1.825% hydrochloric acid solution is needed to neutralize 20 ml B solution. So, my dear students, to solve this question, at first we have to know the concentration of hydrochloric acid. So, our first step is concentration of 1.825% HCl solution. We know that the formula of concentration is S equal to W into 1000 divided by mV. Here given 1.825%, that means W equal to 1.825 gram, volume V equal to 100 ml because here given percentage, and molecular mass of hydrochloric acid is 36.5. So, my dear students, concentration of hydrochloric acid is W 1.825 into 1000 divided by 136.5 into 100. We can say that the concentration of hydrochloric acid is SA because HCl is an acid, and we get the concentration is 0.5 molar. Now, my dear students, here the reaction occurs like this: HCl plus sodium hydroxide reacts and we get sodium chloride plus water. So, if concentration of here concentration of HCl, that is SA, equal to 0.5 molar, volume of HCl VA equal to what, and concentration of sodium hydroxide is B because this is base, that is 0.1 molar. Why 0.1 molar? Because the given concentration of sodium hydroxide, that means B solution, is decimolar, and volume of sodium hydroxide, that is VB, equal to 20 ml. Now we get, my dear students, VA SA equal to VB SB. So what is VA? Equal to VB into SB divided by SA. What is the value of VB? That is 0.1. Value of VB, that is 20 ml, 20 into SB, 0.1 molar, 0.1 molar, and concentration of hydrochloric acid, that is SA, is 0.5 VA, or we get the answer is 4 ml. 4 ml. So, my dear students, to neutralize 20 ml B solution, so my dear students, to neutralize 20 ml B solution in 4 ml HCl solution. My dear students, our next question is question number D. What will be the nature of the mixture if A and B solution are mixed together? Analyze this mathematically. So, my dear students, here given 1% sulfuric acid 250 ml and sodium hydroxide 300 ml decimolar solution. So, to solve this question, at first we have to know the molarity of sulfuric acid. That means molar concentration of sulfuric acid. Concentration of 1% sulfuric acid, H2SO4. We know S equal to W into 1000 divided by mv. Here W equal to 1 gram, volume V equal to 100 ml, molecular mass of sulfuric acid is 98. So, W1 into 1000 divided by 98 into 100, and the answer is 0.1020 molar. So, the concentration of 1% sulfuric acid is 0.1020 molar. Now, my dear students, to convert the concentration into 1 molar, we write 250 ml, 0.1020 molar H2SO4 equivalent to 250 into 0.1020 ml 1 molar H2, 1 molar H2SO4. That is, we get 25.5 ml 1 molar sulfuric acid H2SO4 solution. But this is here in sulfuric acid 2 hydrogen is present, so we write 225.5 into 2 ml 1 molar H plus solution. Okay, my dear students, we get here 51 ml 1 molar H2SO4 solution. Now 300 ml 0.1 molar sodium hydroxide solution equivalent to 300 into 0.1 ml 1 molar NaOH solution, and we get here 30 ml 1 molar sodium hydroxide solution. So, my dear students, here the reaction occurs like this: H2SO4 plus 2 sodium hydroxide equal to Na2SO4 plus 2 H2O. That means hydrogen ion reacts with hydroxyl ion and neutralize by producing water. This reaction occurs if A and B solution mixed together. My dear students, here the reaction occurs like this: 1 mole sulfuric acid reacts with 2 mole sodium hydroxide and produce sodium sulfate plus 2 H2O. The main reaction is hydrogen ion and hydroxyl ion, and it produces water. Okay. Now, if we mixed these two solutions together, then after reaction we get excess hydrogen ion. That means after reaction excess hydrogen ion solution equivalent to 51 minus 30 ml 1 molar H plus solution, and we get here 21 ml 1 molar H plus solution. And to convert this H plus solution again in sulfuric acid solution, we have to divide this 21 by 2. That means 21 divided by 2 ml 1 molar H2SO4 solution, and we get the answer is 10.5 ml 1 molar H2SO4 solution. Here we see that in the mixture 10.5 ml 1 molar sulfuric acid solution remains. So the nature of the mixture is acidic. So the nature of the mixture is acidic. Now we calculate the concentration of the mixture. Concentration of the mixture. At first we write here V1, that is the excess sulfuric acid remains in the solution, that is 10.5 ml, and S1, that means concentration of this sulfuric acid, is 1 molar, and V2 equal to the total volume of the mixture, that is 250 ml plus 300 ml, and we get 550 ml. 550 ml. And what is the concentration? That means S2 equal to what? My dear students, we know that we get V1 S1 equal to V2 S2. So S2 equal to V1 S1 divided by V2. That means S1 equal to V1 equal to 10.5 into S1 1 divided by V2 equal to 550. So the answer is 0.19 molar. So we can write concentration of the mixture is 0.19 molar. My dear students, now I discuss with you our next creative question. Here given sample, reagent and indicator. Sample 1, determine the concentration of 100 ml sodium hydroxide by 10 ml 0.1 molar hydrochloric acid. In this reaction, any indicator can be used. Sample 2, determine the concentration of ammonium hydroxide by 0.1 molar hydrochloric acid, and here we use methyl orange indicator. And sample 3, determine the concentration of sodium hydroxide by 0.1 molar acetic acid. Here we use phenolphthalein indicator. Now question number C. Our first question, calculate the concentration in ppm by the base of sample 1. So here the base is sodium hydroxide, and the given volume of sodium hydroxide is 100 ml, and acid is hydrochloric acid, and given volume of hydrochloric acid is 10 ml, and given concentration of hydrochloric acid is 0.1 molar. Now we have to calculate the concentration of sodium hydroxide in ppm unit. My dear students, solution question number C. Here let concentration concentration of HCl, that is SA, equal to 0.1 molar. Volume of hydrochloric acid, that is VA, equal to 10 ml. Now, volume of sodium hydroxide, VB, equal to 100 ml, and concentration of sodium hydroxide, that is SB, equal to what? My dear students, here the reaction is hydrochloric acid plus sodium hydroxide, and it produces sodium chloride plus water. Here we see that 1 mole HCl reacts with 1 mole sodium hydroxide. So we get VASA equal to VBSB, and for SB equal to VASA divided by VB. So we write here 10 into 0.1 divided by 100, and the answer is 0.01 molar. Now, my dear students, we have to calculate this molar concentration in ppm unit. Now, to convert molar solution into ppm unit, we have to multiply the molecular mass of the compound and 1000. SB equal to 0.01 into molecular mass of sodium hydroxide, that is 40, and we multiply here 1000. Then we get the unit is milligram per liter. Okay, the answer is 400 ppm, because milligram per liter is the unit of ppm. So we can say that the concentration of base in ppm unit is 400 ppm. My dear students, our next question is according to the stem, that means according to the stem, in titration different indicators are used and analyzed. Here we see that we can use any indicator. For sample 1, we have to use methyl orange. For sample 2, and we have to use phenolphthalein for sample 3, and this is the question, that is in titration different indicators are used. My dear students, now we discuss about the question number D. Here in sample 1, here we use hydrochloric acid and sodium hydroxide. Sodium hydroxide is a strong base and hydrochloric acid is a strong acid. The change of pH has been represented by the graph. During titration of strong acid and strong base. It has been seen from the graph that if strong acid is added dropwise into strong alkali solution, first the pH value gets increases gradually, but the pH of the solution near the neutralization point become 3 from 11 by getting reduced suddenly. The solution becomes completely neutralized just after adding small amount of hydrochloric acid to the solution, means the pH of the solution changes suddenly at quicker rate. It is noted that within the range, this range, the graph in the linear shape, this is linear shape, the indicator which changes the color within the pH range suitable for used as indicator, that means 3 to 11 pH range. Basically, any type of indicator can be used in such case, that means for strong acid and strong base titration we can use any indicator. My dear students, here for sample 2 we use ammonium hydroxide and hydrochloric acid. My dear students, we know that hydrochloric acid is a strong acid and ammonium hydroxide is a weak base. Titration of strong acid and weak base, the aqueous solution of salt produced from strong acid and weak base is slightly acidic. For this reason, pH is below 7 at the end point. If solution of strong acid is gradually added in the solution of weak base in the near point, that means end point, the indicator that changes color change from 4 to suddenly. So, the indicator that changes color at a pH range 4 to 7 are used in titration as strong acid and weak base. Here we see that the pH range of methyl orange is 3.1 to 4.4. So, for this type of titration, that means strong acid and weak base, we use methyl orange. My dear students, now we discuss about sample 3. Here we use sodium hydroxide and acetic acid. We see that acetic acid is an weak acid and sodium hydroxide is a strong base. Here given the graph of this titration reaction, we see that if we add sodium hydroxide gradually, the pH changed, that means increases, and near the point of 6, if we add another sodium hydroxide solution or gradually added sodium hydroxide solution, then the pH shifted to nearer 6 to 11. So we have to use that type of indicator which can change color by this range, and for this type of titration we have to use phenolphthalein, because phenolphthalein change its color from 8.3 to 10 range pH. So my dear students, I think that you can understand why we use different type of indicator in this different type of sample. My dear students, now we discuss with you some important multiple choice question from chemistry second paper, chapter 3, quantitative chemistry. Our first question is here: which one is the standard solution? Option A, 1 molar sulfuric acid. Option B, 1 gram sulfuric acid. Option C, 1 ml sulfuric acid. And option D, 1 mole sulfuric acid. Dear students, we know that standard solution is the solution of knowing concentration. So here this is the molar concentration of sulfuric acid, and this is the mass of sulfuric acid, this is volume of sulfuric acid because here given ml, and this is the mole of sulfuric acid. So according to our discussion, we can say that option A is the correct answer, because this is the molar concentration of sulfuric acid. Now next question: in chemical reaction of acidic potassium permanganate, how many electrons are accepted by the central atom of potassium permanganate? My dear students, if we see the acidic reaction of acidic potassium permanganate, we see that KMnO4 reacts and we get K plus manganese 2 plus here 4 plus 4 H2O and here 8H plus, and to balance this equation here 5 electron is accepted by potassium permanganate. So the answer is option D. Now question number 3: the concentration of 1 molar sodium carbonate solution in ppm unit is 106 ppm or 1060 ppm, 5300 ppm or 10600 ppm. We know that ppm equal to 1000 sm. S represent the molar concentration of given solution and m represent the molecular mass of the compound. So if we write here 1000, molar concentration given 0.1 and molecular mass of sodium carbonate is 106. So the answer is 10,600, and according to our discussion we can say that the answer is option D. My dear students, our next question is 80 gram sodium hydroxide is dissolved in 2 liter solution. the concentration of the solution is option A 1 molar, option B 2 molar, option C 0.5 molar, and option D 0.05 molar. My dear students, we know that to calculate the concentration of a solution we use this formula, S equal to W into 1000 divided by mv. So the given weight is 80 gram and molecular mass of sodium hydroxide is 40, and here given the value 2 liter, that means 2 into 1000, and the answer is 1. So we can say that the answer is option A, 1 liter. Now my dear students, next question: which one of the following is a primary standard substance? My dear students, the substance which exists in nature as a pure state and which is not attacked by the component of air such as carbon dioxide, oxygen, water, and which concentration is remain unchanged is primary standard substance. So we can say that potassium dichromate is primary standard substance because this potassium dichromate exists in nature as pure state and it is not attacked by the component of air, and the concentration of the solution of potassium dichromate remain unchanged. Now next question: what will be the molar concentration if 250 ml water is added to 250 ml solution? 250 ml water is added to 250 ml solution containing 22 gram sulfuric acid. So my dear students, the total volume of the solution is 250 ml plus 250 ml, and the weight of sulfuric acid is 22.5 gram. So here we write weight W equal to 22.5 into 1000 divided by molecular mass of sulfuric acid, that is 90, and the total volume is 500, and we get the answer is 0.45 molar. So the correct answer is option B, 0.45 molar. Our next question: what is the concentration of acid when 10 ml 0.5 molar sodium carbonate solution is needed to neutralize 12.6 ml of sulfuric acid solution? My dear students, if we write this is the volume of sodium carbonate, that means V1, and concentration of sodium carbonate is S1, then the volume of sulfuric acid is V2, and concentration of sulfuric acid S2 equal to what? This is the question. So my dear students, we know that V1 S1 equal to V2 S2. So S2 equal to V1 S1 divided by V2, and S2 equal to, here we get S2 equal to V1 equal to 10 into S1 equal to 0.5 divided by volume V2 equal to 12.6, and the answer is 0.396. So we can say that the correct answer is option A. Now, my dear students, option A. Next question: how much volume of water should be added to 10% 250 ml sodium carbonate to make it semi-molar solution? Do you know what is semi-molar solution? 0.5 molar solution is known as semi-molar solution. So at first we have to calculate the concentration of 10% sodium carbonate solution. My dear students, here we see that concentration S equal to W into 1000 divided by MV. For 10% sodium carbonate solution, my dear students, here given 10%. If percentage is given, then we write like this: percentage, that means 10%, 10 gram into 1000 divided by molecular mass of sodium carbonate is 106, and the volume is 100 ml, because here given the percentage. And now we get the concentration 0.94 molar. Okay, now we have to prepare this solution to semi-molar solution. Now, my dear students, if we write like this, the concentration of V1 equal to 250 ml, S1 equal to 0.94, and V2 equal to what? And S2 equal to equal to 0.94. Okay. Now V2 equal to V1 S1 divided by S2, that is 250 into 0.94 divided by S2 equal to 0.5 molar, that is 0.5 molar, and the answer is 470 ml. My dear students, our question is how much volume of water should be added. So water should be added 470 minus 250, that is 220 ml, and that's why our correct answer is option A. Now, my dear students, next question: 5 gram sodium carbonate is dissolved in 100 gram solvent. So how the concentration of the solution can be expressed? That is, option A is W by V, that means weight by volume. Option B, volume by weight. Option C, weight by weight. And option D, volume divided by volume. Here we see that sodium carbonate is 5 gram and the solvent is 100 gram. So the option C is the correct answer, W by W. Students, what is the acidity of ferric oxide? Option A 4, B 5, option C 6 এবং option D 7. My dear students, if ferric oxide reacts with hydrochloric acid, then 6 mole hydrochloric acid reacts with 1 mole ferric oxide. Here 6 mole hydrochloric acid reacts with 1 mole ferric oxide, so we can say that the acidity of ferric oxide is option C 6. Now next question, molarity is variable if there is a change of 1. Volume of solvent, 2. Amount of solute, and third option, temperature. Which one is correct? My dear students, we know that molarity is the concentration of a solution expressed as the number of moles of solute per liter of solution. So we can say that this 1, 2 and 3 all options are correct. So we can say that this options D is the correct answer. And our next question, which of the following values corresponds to 1 ppm? My dear students, we know that the unit of ppm equal to milligram per liter, milligram per liter. So we can say that the option B is the correct answer.